another one. So today I'll be explaining our interesting theorem in math. So we are going to start with experimenting because in order to formulate a pattern, the first step is always to experiment with some small examples. So first of all, let's try 5 squared. What does this equal? Yes, this equals 25. And then now I'm going to try 15 squared. This is 225. And 25 squared equals 625. 35 squared. And if you multiply this out, this will equal 1225. So what do I notice here? Now, I notice that for any positive integer, well, any actually integer in general, ending with the unit digit 5, if I multiply it by itself, then result will always end with 25, as we see right here. So thus, after experimenting with some small examples, we can now formulate a claim. So what is our claim right here? We claim that for any integer, it doesn't have to be positive actually. And to see why in a second, well, if you have a negative and you multiply it by itself, well, your result will be positive. So for any integer ending with 5, with the with 5, all right, I'll just, its square will end in 25. And now we will be trying to proving our claim. All right, so for any integer ending with 5, so if you heard of modular arithmetic, by definition, this means that if we have this integers, if we have an integer n basically, and n ends in 5, then this basically means that n is congruent to 5 mod 10. And another way to explain this is that if you divide the number n by 10, your remainder is 5. And basically, we want to prove that n squared, so if n is congruent to 5 mod 10, we want to prove that n squared is congruent to 25 mod 100. Alright, so we start with this statement right here. And if you divide n by 10 and your remainder is 5, then n equals, then we can write n as 10k plus 5, where k is an integer. And this is what we want to directly show. So we want to directly show that 10k plus 5 squared, you square that, is congruent to 25 mod 100. Yeah, so this basically means that if you divide this number by 100, your remainder is 25. And after expanding this out, so I'll do it here. So 10k times 10k is 100k squared. 5 times 10k, which is 50k, and it will be the same here. And 5 times 5 is 25. So therefore, 10k plus 5 squared, you add all this up, and you will get 100k squared plus 100k plus 25. Alright, so what do we notice here? So 100k squared, well, this is divisible by 100 because it has a factor of 100. And 100k is also divisible by 100 because it also has a factor of 100. while if you divide 25 by 100, your remainder will be 25. Therefore, we have 100k squared plus 100k plus 25 is congruent to 0 plus 0 plus 25 mod 100. And this thing right here, well, this equals 25. So therefore, we have shown that if n equals 10k plus 5, if you square that, then if you divide this number by 100, your remainder will always be 25. Yeah, so this is the modular arithmetic way of proving this. If you're not familiar with this, well, I guess you can search up online of what this is. It's basically like the fundamentals of modular arithmetic. So thank you guys for watching, and hope to see you next time.